All right, 4.6, solving linear systems in 3 variables. So this is where things start to get a little bit tougher. We have 3 equations, 3 unknowns. All the systems we've done so far have only had x's and y's. These are going to be x, y, and z. So it's just a little bit long, well, not a little bit longer, it's quite a bit longer trying to solve these by hand. Eventually I'll show you how to use matrices on your graphing calculator and speed up the process. So far we've solved systems, 2 unknowns, we've graphed them. Just kind of a quick review because it ties into what we're doing today. When you solve a system by graphing, remember there's 3 things that can happen. The 2 lines cross, so that was a situation where the system had exactly 1 solution. We graphed the 2 lines and they were parallel, so that was when there was no solution. And then we had the situation where we graphed the line and it was right on top of itself. There were kind of 2 lines on there, and that was the infinite solutions. So that's what happens when you graph lines. There's 3 possibilities. Well, when you graph a 3x3 system, you're not graphing lines, you're actually graphing planes. And we use Geogebra 3D, and I'll show you that here towards the end of the lesson. Maybe I'll write it down over here. I really like using this just to kind of visualize the 3D stuff. It's pretty cool. But you get 3 planes, and now 3 planes can interact a lot of different ways. So I say here that there's several possibilities of how 3 planes can interact with each other, which determines the number of solutions to the system. So below are some of the possibilities. So remember, to be a solution to the system, you have to be the intersection of all 3. All right? So when you look at the no solutions, you have this first kind of version where the 3 planes are all parallel to each other. They have no points in common. There's no points that are common with any of them, so it's no solution. When you look at this other one, you'll notice that you do have this intersection line, but those are only the solutions that the blue and the green share. And there's no red solutions in there. And then if you look down lower, this is the intersection where the red and the green share all those solutions, but the blue's not involved. So there's still no common points between all 3 planes. Then the other way you could kind of make this tent looking feature here, we're a similar idea, the blue and the green share solutions, the red and the green share solutions, and then back here is the blue and the red, which, it would continue. You just can't see it right now. But again, there's nowhere where all 3 colors are touching in the same exact place. Now, that's the no solution scenario. The 1 solution scenario would be right here. I almost kind of visualize it like 4 desks together, and then they put some sort of divider, some cubicle, so you can't see each other. But that point right in the very center there, that would be the 1 solution to the system. And when you're graphing in 3D, our solutions are going to be represented as an ordered triple. It's going to be an x, a y, and a z. There's going to be 1 number for each of those that solve the entire system, the 1 magic key that unlocks it. And then, of course, you have infinite solutions. And just like before it was where 1 was on top of each other, you could have all 3 of them crossing at the same line here. All of these set of ordered pairs, or ordered triples, I should say, all of those dots, and there's an infinite because it goes forever. That line right there would be the intersection of the 3 planes, and that would be the infinite solutions. So visually, that's kind of what's going on if we were to graph these using boy, I can't say my S's today, Geogebra 3D. But we're going to get into the mechanics, the algebra. So let's kind of tackle this. So we're going to solve this algebraically. And typically how I like to do it is I like to use elimination. That's usually a pretty good strategy for most of these. And my first goal, my sub-goal, is I want to eliminate 1 variable because I want to get this thing down to a 2x2 system. Like if I can get it down to a 2x2 system, I can use what we've done in previous sections. So let's get after it. This is going to be some work. So I start glancing through these things and I look for opposites. And when I'm looking through, I don't see any opposites with the x's. Now I could multiply through by a -2 and get it, but I'm looking for easy marks first. And the thing that I notice right away is I notice that, wait a minute, I got a +2y and a -2y. I could eliminate y's from those two equations. So what I'm going to do is I'm going to kind of ignore the bottom one right now. Don't do this on your own paper, but I'm going to do it just so we have less to look at. I'm going to ignore this, and I'm going to combine those first two equations. And I'm going to get 3x plus, no, not plus, minus 2z equals 5. And over here to the side, I'm going to just kind of write down what I did. I added equations 1 plus 2 together. So this is just kind of my mental notes over here. These are kind of like my little thought bubbles. So maybe later on if I screw up, I can maybe identify what happened, because there's going to be a lot of work on these problems. Now, so since I eliminated y, that's kind of my strategy. I'm like, hey, I'm going to eliminate y. I now need to get another 2 by 2 with no y in it. So I'm going to go back to the original, and I've already used 1 and 2 together. So my other options now are either 1 and 3 or 2 and 3. So I'm going to kind of peek at, looking at 1 with 3 or 2 with 3, and I'm going to see, well, how can I get rid of my y's? Well, unfortunately, I don't have any opposites. When I look at 1 and 3, I'm like, oh, trying to get rid of y's, I don't have them yet. So, there's nothing easy there. When I look at 2 and 3, I'm like, well, I don't see anything easy there. So it looks like I'm going to have to multiply a row before I combine. So I think what I'm going to do to get some opposites, I think I'm going to multiply this bottom row by a +2, and that'll give me some opposites. So I like to kind of go off to the side and do some scratch work. So I'm going to go off to the side, and I'm going to copy down row 2, and I'm going to multiply row 3 by 2. So I'm going to get 2x plus 2y plus 4z equals -8. And then I'm going to combine those together, because now I should be able to eliminate y's. So I'm going to get 4x, you're gone, 5z, and then that would be a -1. So now I have another equation here without a y in it. So I said, okay, I got 4x plus 5z equals -1. So what I've done is I've taken a system, a 3 by 3, 3 equations, 3 unknowns, and I've kind of shrunk it down to a 2 by 2. And a 2 by 2 I know how to solve. So now I can just get after solving it just like I would, before. And we can try to kind of figure this thing out. So looking for opposites, I don't have any here, I don't have any here. So it looks like I'm going to have to multiply both rows. So I'm going to multiply this row by 4 and maybe this row by -3. That way I can get opposites and x's here. So on the top I have 12x minus 8z equals 20. Bottom row I'm going to have -12x minus 15z equal +3. And I can now eliminate x's. All I have are z's left. And these are all going to come out to be whole numbers or integers today. No decimals. So if you get a decimal, you made a math error somewhere. And this one comes out pretty clean in that z equals -1. Now, once you get that first unlock, once I get the z equals -1, then it's all going to start falling into place. Because now, come back. Now I can go and I can substitute this -1 in to either one of these two 2x2 equations, and I should be able to get x. So that's going to unlock x. So let's unlock x. I'm going to use the bottom equation. 4x plus 5 times a negative 1 equals negative 1. So that's 4x subtract 5 equals negative 1. And add 5 to both sides. I was a little worried. I thought I was going to get a 6 here. Add 5 to both sides. I'm going to get 4. And boom, we just got our second feature. So now, what's pretty cool is now I can go back and I can go to the original top 3. And I can choose, and I now can plug in x equals 1. So maybe I'll just go here to this bottom one. I can put in an x equals 1. I can put in this z equals negative 1, and that'll only leave y. So let's go up here. I got x plus y plus 2, and instead of z, I can put the negative 1 in. And I clean this up. That's 1 plus a negative 2, so that's a negative 1 plus y equals negative 4. Add 1 to both sides, and I will get y equals negative 3. Whew, that's a lot of work, a lot of equations, but I do have all 3 of them. So if you want to check your work in TeacherMade, you're going to put in the ordered triple with no spaces and parentheses. Just put in x, comma, y, comma, z. So if I were to graph those 3 planes, they would all cross and intersect at exactly one point, and this would be the point in coordinate space where they all share. You know, algebraically, that's the combination that I can plug into that system, and all of those equations are going to be true. It's the only triple out there. It's the only XYZ combination that works. So, pretty tough one. All right, let's move in and let's do another one just to get some reps. There's not going to be a lot of homework on this section just because these questions take a little bit, man. They're kind of tough. And there's so many different ways to do it. Different people are going to have different strategies about how they want to plan their attack. There's just a lot of combinations. So again, first thing I do is I look at this thing and I'm like, do I have any opposites given to me? If I don't, I got to start multiplying rows and adding together. But I see, peeking at all the y's and z's and x's, I do see a pair of opposites right here. So I'm going to start off by combining 1 plus 3, kind of like I did in the last one. So I'm going to add 1 plus 3 together, and I get, what's that, positive 2y. Well, let me fatten this up a little bit. Positive 2y, negative 3z, and that's a negative 1. So that's what happens when I added row 1 plus row 3. And some people even like to write that out. You know, they might write the r in there and actually show, you know, if I put thinner here, you could say row, doggone it, row 1 plus row 3. So I add those together. Well, now I have to eliminate x's from my next one. I don't really want to focus on any other letter. I've kind of went down the road, said I'm going to eliminate x's. So now I have a choice to do it either between 1 and 2 or 2 and 3. And no matter which way I go, it looks like I'm going to be forced to multiply a couple different rows. I'm going to go this route. I'm going to multiply this row by 5 and this row by 4. And what that's going to do is going to give me some opposite x's. So I'm going to go over here to the side and I'm going to kind of go down that route. So I'm going to say 20x minus 15y minus 30z equals 40. So many ways to make a mistake on these problems, so be careful. Negative 20x. I'll actually be shocked if I don't screw up somewhere here. Plus 4z here's usually where I screw up. I forget to multiply all the way through. Negative 16. So if you do want to show what just happened, what we did was we multiplied 5 times row 2, and then we multiplied 4 times row 3, like if you're trying to kind of describe your work. And now if we combine those rows, if we add them together here, let's see what we get. Well, I eliminated x's, which was my goal. I got 1y minus 27z equal 24. Oh man, this seems kind of nasty, but I don't know. We'll see where we're at. Hopefully I didn't screw up anywhere. 20, negative 15, negative 30, positive 40, negative 20, positive 16, positive 4. Looks good. Add them up. No, it's not 27. See where I made a mistake right there. Glad I kind of double checked this before I got too far into it. That's a negative 26. That one's a positive 24. All right, I think I'm good. So now I come back over here and I'm like, all right, I got another equation here without an x. So now I think we can go into familiar territory. We've got our 2 by 2 locked down. Now we can just solve it. So I'm trying to get opposites here. It looks like I'm going to have to multiply my bottom row by 2. So if I multiply the bottom row by 2, I'm now going to have top row I leave alone. Bottom row multiplied by 2. All right. And actually, I didn't want to multiply by 2. I want to multiply by negative 2. So change that, change that, change that. So actually, I multiplied over here times this row by a negative 2. And what shakes out is that goes away when I combine them. And I get positive 49 z. Whew. I must have did this one different than the one in the notes just because all these numbers look different. I was getting a little bit scared. It looks like z is negative 1. That feels good when you don't have a decimal. So now I got to go into the double substitution game. So now I need to take this negative 1 and I need to jam it in here first, and that'll give me my y. So let's kind of go down this road. Y minus 26 times z equals 24. So that's y plus 26 equals 24. Subtract 26, subtract 26. I get y is negative 2. Boom, another unlock. And it's no decimal, so life is good. Now I got to go back to my original equations up top here. And I need to plug in both of this one and this one up in the top. So I'm going to choose this top row, and I'm going to go after x. So 5x minus 2y minus 4z equals 3. So just to show you what I did, I took this 2 and I plugged it in right there. And then I took this negative 1 and I plugged it in right there. And I'm trying to get this x right here. So that's what all my work right here is showing. So we have 5x, that's plus 4, plus 4, plus 4, plus 4, yeah, seems like it, equals 3. So that's 5x plus 8 equals 3. Again, I got nervous because I thought an 11 was going to shake out, but it actually turns into a negative 5, which is beautiful. Awesome. X equals negative 1. So I believe this point where they all cross is negative 1, negative 2, negative 1. So if you think about that, negative 2, negative 1, negative 2, negative 1. If you think about that, I want to just kind of sketch it out. Whoop. Hold on. Whoop. Let me go back and make sure I remember what I just had. Negative 1, negative 2, negative 1. Negative 1, negative 2. I'm writing it on the board just so I don't forget. So if I sketch this out, I should be able to see the point where they all cross. So I'm here, and I'm here, and then I'm here, and this is X, this is Y, this is Z. Different websites and different books do it differently, but this seems to be the most traditional way. Although Geogebra seems to do it a little bit different when I kind of notice their points. And then back this way would be negative. And this way would be negative. And that away. Oh, it's kind of a crooked line. That way is going to be negative. All right, and our point needed to be at negative 1, negative 2, negative 1. So negative 1 on the x-axis would go backwards this way. Negative 2 on the y-axis is going to go left 2. So let's link up where those go together. If I kind of make a box out of this. So now I'm back there. That would be at back 1, left 2. Now I got to go down 1. So going down 1 puts me down to here. And if I connect the box and I go down and down, and I kind of fill in the rest of this box, it looks like my dot is somewhere back here on that bottom corner. Now it looks like it's on the Y line, but it's actually behind it and down, just because that's the top of this box is actually flush with the plane. So we're actually down below the plane a little bit. We're like one layer down. So I know that's kind of tough to visualize for some of you guys. Like right now, this is the top of the box. And the top of that box is basically the top of this plane back here. So our red dot is actually under that plane. Now what I did was I graphed this. And so I'm going to sneak off here to Geogebra. And I believe it was this equation. Go back and hopefully it's this one. Yeah, right here it is. I got all three of them in there. And it's kind of cool. You can see where all the three planes align. Red is the X and green is the Y. So this is kind of how we've been drawing it, where the red is coming out at me. So the intersection point should be back down under the plane. And if I kind of tip it up, I can kind of see that point right there is where all three of those planes cross. It's pretty tricky to kind of see. You got to kind of keep tilting it and turning it around. Now this is not a bad view either. Right there is where all these planes intersect. So I got to kind of tip the plane up, and then I can kind of look at, where they cross. Right there's another good spot at seeing it. But pretty cool being able to spin these things around and see that magic crossing point happen. But something you could play with later on if you'd like to. All right, hopefully this video helped you out, and hopefully you're able to solve systems of equations with 3 unknowns. See you.